The mission was already compromised when the first pilot collapsed. The second pilot never made it to the briefing room. 3 hours before the most classified operation in military history, the $2.1 billion stealth bomber sat on the tarmac like a sleeping giant, and the only person who knew every bolt, wire, and system in that aircraft was someone they'd never let fly it. They called her just a mechanic. They were wrong. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The alarm clock never rang at 0430 hours because Riley Chun had been awake for 10 minutes already. Her internal chronometer had calibrated itself to the rhythm of Holloman Air Force Base years ago, synchronized to the pulse of engines that most people only heard during daylight hours, while the rest of the base slept through the last precious minutes before reveal. She was already lacing her steel-toed boots in the pre-dawn darkness, her flight suit pressed and ready, even though she wasn't authorized to fly anything. The walk to Hangar 7 took exactly 4 minutes and 37 seconds. Riley had timed it countless times, not out of obsession, but out of necessity. Every second mattered when you were responsible for maintaining the most sophisticated aircraft ever built. The hangar doors stood 40 feet tall, painted in standard military gray that looked almost black in the early morning light. Behind those doors waited the B-2 Spirit, call sign Ghost Rider, a flying wing that cost more than most small countries' entire defense budgets. Riley's toolbox was organized with surgical precision. Every wrench, every diagnostic device, every specialized instrument had its designated place. She'd memorized the location of each tool so thoroughly that she could grab what she needed in complete darkness. This wasn't standard procedure, it was her procedure. The technical manual said routine maintenance required a 3-person crew and minimum 4 hours per inspection. Riley completed the same work alone in 2 hours and 43 minutes, and she'd never missed a single anomaly. The B-2's skin was unlike anything else in the sky. Composed of radar-absorbing materials that had to be maintained at precise temperatures and humidity levels, the aircraft's stealth coating required constant attention. Riley moved around the wing with practiced efficiency, her hands reading the surface like Braille. She could detect a microscopic crack in the composite material by touch alone, feel the slightest irregularity in the seamless curves that made the bomber invisible to enemy radar. Her checklist was 3 times longer than the official version. While regulations required inspection of primary systems, Riley examined everything. She traced electrical conduits with her fingertips, checking for heat variations that might indicate failing connections. She measured hydraulic fluid levels with calipers accurate to thousandths of an inch. She tested backup systems that most mechanics never accessed, verifying response times on components that would only activate in catastrophic failure scenarios. The cockpit was forbidden territory for someone with her security clearance. Maintenance personnel weren't authorized to power up flight systems or access navigation controls. But Riley had found ways to learn without violating protocols. During scheduled system tests, she positioned herself where she could observe the pilot going through startup procedures. She memorized the sequence of switches and displays, the rhythm of system initialization, the subtle sounds that indicated proper functionality. Late at night, when the hangar was empty except for security patrols, Riley would sit in the crew chief station and study technical drawings by flashlight. She'd acquired pilot training manuals through unofficial channels, borrowed from friends in other units, photocopied from library reserves, downloaded from military databases she technically had access to but wasn't supposed to use for personal education. Her bunk was surrounded by stacks of flight procedures, aerodynamics textbooks, and tactical manuals that had nothing to do with her official duties. The B-2's flight characteristics were unlike conventional aircraft. Its flying wing design created unique aerodynamic properties that required specialized piloting techniques. Riley had studied every aspect of its flight envelope, from takeoff parameters to high-altitude cruise configurations. She knew the aircraft's maximum G-loading, its fuel consumption rates at different altitudes, and the precise angle of attack required for optimal stealth performance. More importantly, she understood how all these systems integrated during combat. Operations. Her unofficial education extended beyond technical knowledge. Riley had analyzed after-action reports from previous B-2 missions, studying how pilots had responded to various scenarios. She'd memorized emergency procedures for situations that had never occurred, but theoretically could. She knew the aircraft's performance limitations in different weather conditions, its vulnerability windows during certain flight profiles, and the electronic countermeasures that enemy forces might employ against it. The other mechanics respected her expertise but didn't understand her dedication. They'd finish their assigned tasks and head to the recreation center or the base exchange. Riley would remain in the hangar, running additional diagnostics or studying maintenance logs from other B-2 squadrons. She'd identified patterns in component failures that weren't documented in official reports, correlations between environmental conditions and system performance that could predict maintenance needs weeks in advance. Her personal logbook contained detailed records of every minute spent working on Ghost Rider. She tracked not just maintenance activities but operational patterns, pilot preferences, and mission-specific configurations. Over 3 years, she'd accumulated more hands-on experience with the B-2 than many pilots had flight hours. She knew the aircraft's personality, how its engines sounded when they were running optimally, how the flight controls felt when hydraulic pressure was dropping, how the radar systems behaved during different atmospheric conditions. The weapon systems were particularly complex. The B-2 could carry conventional bombs, nuclear warheads, or precision-guided munitions, each requiring different loading procedures and safety protocols. Riley had studied the technical specifications for every weapon in the aircraft's inventory. She understood the electrical interfaces, the mechanical release mechanisms, and the targeting systems that guided munitions to their destinations. This knowledge was far beyond what her position required, but she believed that understanding the complete system made her a better mechanic. Navigation and communication systems were equally sophisticated. The B-2 relied on multiple redundant systems to maintain its stealth profile, while navigating precisely to targets thousands of miles away. Riley had learned to troubleshoot GPS anomalies, repair satellite communication links, and calibrate inertial navigation systems. She could identify electronic interference patterns and implement countermeasures that weren't in the standard technical orders. During scheduled training exercises, Riley would observe pilots preparing for missions. She'd watch them review weather reports, study target intelligence, and calculate fuel requirements. She began to understand the decision-making processes that occurred before and during flight operations. This insight helped her anticipate maintenance needs and prepare the aircraft for specific mission profiles. Her workshop became a laboratory for innovation. Using spare parts and discarded components, Riley built test fixtures that could simulate various failure conditions. She could replicate electrical faults, hydraulic malfunctions, and sensor anomalies without compromising the actual aircraft. These simulations allowed her to practice troubleshooting procedures and develop more efficient repair techniques. The flight simulator building was off-limits to maintenance personnel, but Riley had found ways to gain access during off-duty hours. She'd befriended instructors who occasionally needed technical support for the simulator systems. In exchange for her expertise in maintaining the complex computer systems, she was allowed to observe training sessions and occasionally operate the simulator controls. Her understanding of the B-2 systems extended to its operational limitations. She knew the aircraft's maximum range with different fuel loads, its ceiling limitations at various weights, and the performance penalties associated with different external conditions. This comprehensive knowledge made her invaluable for mission planning support. Even though she wasn't officially assigned to those duties, the stealth technology was the most closely guarded aspect of the B-2's design. Riley had studied the physics of radar cross-section reduction, the materials science behind absorptive coatings, and the geometric principles that made the aircraft invisible to enemy detection systems. She understood how minor maintenance errors could compromise the entire stealth profile, potentially making the aircraft vulnerable to sophisticated air defense systems. Her commitment to excellence was driven by more than professional pride. Riley understood that her work directly impacted the safety of aircrew and the success of critical missions. Every system she maintained, every component she inspected, every procedure she perfected could mean the difference between mission success and catastrophic failure. This responsibility was both a burden and a motivation that pushed her to achieve standards far beyond what was required. The other mechanics began to rely on her expertise for complex problems. When diagnostic equipment couldn't identify a fault, they'd asked Riley to examine the system manually. Her ability to detect subtle anomalies through sensory observation had become legendary among the maintenance crew. She could hear electrical arcing that instruments couldn't measure, feel vibrations that indicated bearing wear, and spot discoloration that revealed thermal stress in components. 3 years of intensive study and hands-on experience had transformed Riley from a skilled mechanic into something else entirely. She possessed technical knowledge that rivaled engineering specialists, operational understanding that matched experienced pilots, and troubleshooting abilities that exceeded standard protocols. But officially, she was still just a mechanic, assigned to maintenance duties and excluded from operational planning. Her security clearance granted access to technical specifications, but not to mission details. She could maintain the aircraft's weapon systems, but wasn't briefed on target selection or tactical employment. She understood every aspect of the B-2's capabilities, but wasn't authorized to participate in operational decisions. This separation between technical expertise and operational authority was about to become critically important. The morning of October 15th began like any other. Riley completed her pre-dawn inspection of Ghostwriter, documenting minor discrepancies and scheduling routine maintenance tasks. The aircraft was in perfect condition, every system functioning within specifications. She had no way of knowing that in less than 12 hours, her unofficial education would become the most important qualification anyone on the base possessed. Colonel Marcus Brennan commanded the 509th Bomb Wing with the confidence of someone who had never been wrong about anything that mattered. His office walls displayed 30 years of military decorations, photographs with defense secretaries, and framed mission patches from classified operations that most people would never know existed. At 52, he carried himself with the bearing of an officer who had earned his position through combat experience and political acumen in equal measure. When he spoke, subordinates listened, not just because of his rank, but because his decisions had shaped strategic operations across 3 different theaters of conflict. The morning briefing room buzzed with the controlled energy of senior staff preparing for something significant. Maps covered every available wall surface, displaying satellite imagery, intelligence overlays, and flight corridors marked with classifications that required special authorization just to view. Major Thompson, the wing's director of operations, stood beside a digital display showing weather patterns across the eastern Pacific. Captain Rodriguez, the intelligence officer, shuffled through classified folders marked with red diagonal stripes. These were people accustomed to making decisions that affected national security, individuals whose recommendations could alter the course of international conflicts. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Flight crews occupied the front rows with the casual confidence of elite aviators. Captain Jake Morrison and Lieutenant Colonel Sarah Hayes had been selected as the primary crew for the upcoming mission, their combined flight hours exceeding most pilots' entire careers. Morrison had flown penetration missions over heavily defended airspace in 3 different conflict zones. Hayes specialized in electronic warfare and had developed countermeasures against advanced surface-to-air missile systems. Behind them sat the backup crew, equally qualified professionals who understood that their role existed as insurance against the unpredictable nature of military operations. The maintenance personnel occupied chairs along the side walls, a clear delineation between those who flew the aircraft and those who prepared them for flight. Technical Sergeant Williams led the crew chiefs, veterans who had maintained strategic bombers for decades. Staff Sergeant Martinez supervised the avionics specialists, technicians whose expertise kept the most sophisticated electronic systems in the military functioning flawlessly. These were skilled professionals whose work enabled every mission, but the briefing room seating arrangement made their secondary status unmistakable. Riley sat in the back corner, her presence barely acknowledged by the flight crews or senior officers. Her coveralls bore grease stains that marked her as someone who worked with tools rather than tactical displays. When maintenance issues arose during briefings, the questions were directed to Technical Sergeant Williams or the other crew chiefs. Rayleigh's insights about aircraft systems were filtered through supervisors who presented her technical recommendations as their own analysis. The hierarchy was clear, and unquestioned pilots made operational decisions. Officers provided strategic guidance, and mechanics performed assigned tasks without participating in mission planning. Colonel Brennan began the briefing with characteristic directness. The target was a heavily fortified research facility located 800 miles inside hostile territory. Intelligence indicated the development of advanced weapons systems that pose significant threats to regional stability. The facility was protected by integrated air defense networks that included early warning radars, surface-to-air missile batteries, and fighter aircraft on continuous alert. Conventional attack options had been assessed and rejected due to unacceptable casualty projections and limited probability of success. The B-2 Spirit represented the only viable approach for this mission. Its stealth characteristics would allow penetration of enemy airspace without detection. Its payload capacity could deliver sufficient ordnance to neutralize the target completely, and its range enabled operations from secure bases thousands of miles away. The mission profile required precise navigation through multiple threat zones, coordination with electronic warfare assets, and split-second timing to avoid detection during the final attack phase. Major Thompson outlined the flight plan with practiced efficiency. The route would take Ghost Rider across international waters before turning toward the target area, maintaining altitudes and airspeeds calculated to minimize radar cross-section while avoiding commercial air traffic corridors. The aircraft would refuel twice during the mission, rendezvous with tanker aircraft at predetermined coordinates where enemy surveillance was minimal. Electronic support measures would create false signatures to mask the bomber's approach, while communication protocols would maintain contact with command authorities throughout the operation. Captain Rodriguez presented intelligence assessments with the methodical precision of someone accustomed to briefing classified operations. Enemy air defenses included Russian-manufactured S-400 systems with enhanced tracking capabilities, complemented by older but still effective SA-6 and SA-8 mobile units positioned throughout the region. Fighter aircraft included advanced interceptors with look-down radar systems capable of detecting low-flying targets under optimal conditions. The weather forecast predicted scattered cloud cover that would provide additional concealment, but might complicate navigation during the final approach. The crew assignments were announced without discussion or debate. Captain Morrison would serve as aircraft commander, with Lieutenant Colonel Hayes as mission pilot responsible for weapons systems and electronic countermeasures. The backup crew would remain on standby throughout the operation, prepared to assume the mission if circumstances required crew substitution. Ground support personnel would monitor aircraft systems remotely, providing technical guidance if maintenance issues arose during flight operations. Riley listened to the technical discussions with growing concern about details that others seemed to dismiss as routine considerations. The mission profile required sustained flight at maximum surface ceiling, operating conditions that placed unusual stress on engine systems and environmental controls. The weapon load exceeded standard configurations, affecting aircraft center of gravity and requiring modified flight control inputs during certain phases of the mission. The electronic countermeasures package included experimental systems that had limited operational testing under combat conditions. When Technical Sergeant Williams was asked about aircraft readiness, he provided the standard response that Ghost Rider was fully mission capable with all systems functioning within normal parameters. Riley knew this was technically accurate but incomplete. The aircraft had experienced intermittent fluctuations in hydraulic pressure during recent test flights, anomalies that fell within acceptable tolerances but indicated potential component degradation. The radar warning receiver had shown delayed response times during electronic warfare exercises, a symptom that could compromise defensive capabilities if enemy threats exceeded anticipated parameters. Her knowledge of these issues came from personal observation and analysis that went beyond standard maintenance procedures. The hydraulic fluctuations occurred only during specific flight profiles that combined high altitude with rapid control inputs, conditions that matched the mission requirements exactly. The radar warning receiver delays were correlated with electromagnetic interference patterns that resembled the enemy's known electronic warfare capabilities. These connections were apparent to someone who understood both aircraft systems and operational requirements, but the briefing format didn't allow for detailed technical discussion. The mission timeline was compressed due to intelligence indicating that the target facility was approaching operational status for its weapons development program. Normal preparation periods would be reduced, with flight crews receiving abbreviated rest intervals and maintenance personnel working extended shifts to ensure aircraft readiness. The pressure to execute the mission quickly created an environment where detailed analysis might be sacrificed for operational urgency. Colonel Brennan concluded the briefing by emphasizing the mission's strategic importance and the exceptional capabilities of the selected crew. He reminded everyone that operational security required absolute discretion about mission details, even among personnel with appropriate security clearances. The success of this operation could significantly impact regional stability and demonstrate the continued effectiveness of strategic deterrence capabilities. Failure was not an acceptable outcome. As personnel filed out of the briefing room, conversations continued in small groups discussing specific aspects of their responsibilities. Flight crews reviewed navigation charts and weapon employment procedures. Intelligence officers coordinated with communications specialists about real-time information updates during the mission. Senior officers discussed contingency plans and alternative approaches if primary objectives couldn't be achieved. Riley remained seated while others departed, studying her notes about aircraft systems and mission requirements. She had identified several potential complications that weren't addressed during the briefing, technical issues that could become critical if operational conditions deviated from planned parameters. The hydraulic system anomalies could affect flight control response during combat maneuvering. The radar warning receiver delays could compromise crew awareness of incoming threats. The experimental electronic countermeasures might interfere with other aircraft systems in ways that hadn't been fully tested. Her position in the maintenance hierarchy meant that these concerns would need to be communicated through proper channels, filtered through supervisors who might not understand the technical implications or operational significance. Technical Sergeant Williams was competent, but focused on standard procedures rather than theoretical possibilities. The crew chiefs were experienced but didn't possess the comprehensive system knowledge necessary to evaluate complex interactions between multiple aircraft components. The flight crews had decades of experience, but limited technical training about the specific systems that could affect their mission performance. They understood operational procedures and tactical employment, but relied on maintenance personnel to ensure that aircraft systems functioned as designed. The separation between operational and technical expertise created gaps in understanding that could become significant if unexpected situations arose during the mission. Riley's unofficial education had bridged this gap, providing her with both technical knowledge and operational awareness that no one else on the base possessed in combination. She understood how aircraft systems would behave under the mission's demanding conditions and could predict potential failure modes that might not be apparent until critical situations developed. Her insights could prevent mission failure or save lives, but the established hierarchy provided no mechanism for incorporating her expertise into operational planning. The afternoon was spent in mission preparation activities that followed established protocols without consideration for the unique challenges this operation would present. Flight crews reviewed standard procedures, while maintenance personnel completed routine inspections using normal criteria. The disconnect between operational requirements and technical realities was invisible to everyone, except someone who understood both domains completely. As evening approached, Riley realized that her comprehensive knowledge of Ghost Rider's systems and the mission's technical demands would remain unutilized unless circumstances forced recognition of her capabilities. The hierarchy that dismissed her as just a mechanic was about to encounter a situation where technical expertise would become more valuable than rank or traditional authority structures. The first anomaly appeared during the pre-flight engine test at 13:47 hours, 17 minutes before the scheduled crew briefing. Riley was positioned beneath the starboard engine intake, monitoring acoustic signatures through a digital analyzer that wasn't part of standard maintenance equipment. She had acquired the device through unofficial channels, understanding that subtle changes in engine harmonics could indicate developing problems weeks before conventional diagnostics detected them. The frequency pattern showed a deviation of 0.3 Hz in the high-pressure turbine section, barely perceptible to human hearing but significant enough to suggest bearing wear that could accelerate under sustained high-altitude operations. Technical Sergeant Williams was reviewing the official engine parameters at his diagnostic station, observing readings that fell comfortably within acceptable ranges. Oil pressure, temperature, and vibration levels all displayed green indicators on the maintenance computer. The variance that Riley detected wasn't captured by standard monitoring systems because it occurred only during specific power settings and atmospheric conditions. She approached Williams with her findings, explaining the acoustic analysis and its implications for extended flight operations at maximum service ceiling. Williams examined her data with the polite attention of a supervisor humoring a subordinate's concerns. The unofficial equipment she had used wasn't approved for maintenance decisions, and the deviation she identified fell well below thresholds that would trigger maintenance actions according to technical orders. He acknowledged her diligence but explained that mission-critical decisions couldn't be based on theoretical possibilities or equipment that wasn't part of certified procedures. The engine had passed all required tests and was cleared for flight operations. Riley persisted, explaining that the specific mission profile would subject the engines to sustained, high-altitude operations where the identified anomaly could progress rapidly. The combination of reduced atmospheric pressure, extreme temperatures, and continuous maximum power settings created conditions that could transform minor bearing wear into catastrophic failure. She had analyzed similar patterns in maintenance. logs from other B-2 squadrons, and found correlations between acoustic deviations and subsequent engine failures during demanding missions. The response was professionally dismissive. Williams reminded her that experienced crew chiefs had maintained strategic bombers for decades without needing experimental diagnostic techniques. The aircraft had undergone comprehensive inspections by certified technicians using approved procedures. Mission planning included safety margins and contingency procedures for various failure scenarios. Her concerns, while demonstrating commendable attention to detail, weren't supported by standard maintenance criteria or operational necessity. The second warning sign emerged during communication system testing at 15:23 hours. Riley was calibrating backup navigation equipment when she detected irregular patterns in the satellite communication array. The primary systems functioned normally, but the redundant channels showed intermittent signal degradation that correlated with specific antenna orientations. The pattern suggested potential interference from the aircraft's own electronic countermeasures, a possibility that could become critical if primary communication systems failed during the mission. She documented the interference pattern and calculated the geometric relationships between antenna positions and countermeasures equipment. The analysis revealed that certain flight attitudes would create electromagnetic shadows where backup communications might be compromised. During normal operations, this wouldn't be significant because pilots could adjust aircraft orientation to restore signal quality. However, the mission profile included extended periods where tactical considerations would dictate specific flight attitudes, potentially creating communication blackouts at critical moments. Captain Rodriguez was reviewing intelligence updates in the operations center when Riley attempted to present her findings. The communications officer, Lieutenant Patterson, was present to address any technical questions about the mission's communication requirements. Riley explained the interference pattern and its potential impact on backup systems during specific phases of the mission profile. She recommended additional testing to verify the interaction and develop procedures for maintaining communication if primary systems failed. Lieutenant Patterson examined the data with professional skepticism. The communication systems had been tested extensively during development and operational evaluation. The interference pattern Riley identified was within normal parameters for complex electronic systems operating in close proximity. Backup systems were designed to function under adverse conditions, and mission procedures included protocols for communication failures. Her analysis, while technically interesting, didn't indicate problems that required operational modifications. Riley pressed her case, explaining that the specific combination of flight attitude, countermeasures activation, and geographical location during the mission could create a unique scenario where multiple backup systems might be simultaneously compromised. She had modeled the electromagnetic environment using software that wasn't available to most maintenance personnel, analysis that revealed interactions between systems that standard testing couldn't reproduce. The response reflected institutional confidence in established procedures. Communication systems had been thoroughly evaluated by engineers with advanced degrees and years of experience in electronic warfare. The mission had been planned by specialists who understood the technical requirements and operational constraints. Riley's concerns, while showing impressive technical curiosity, weren't based on approved analytical methods or supported by official testing procedures. The third anomaly surfaced during hydraulic system evaluation at 16:48 hours. Riley was performing pressure tests using procedures that exceeded standard requirements, measuring response times and pressure variations across the complete operating envelope rather than just at specified test points. The data revealed subtle inconsistencies in actuator response during rapid control inputs, variations that could affect aircraft handling during combat maneuvering or emergency situations. The hydraulic systems met all performance specifications during normal testing, But Riley's extended analysis showed degradation patterns that became apparent only under extreme operating conditions. The mission profile included scenarios where pilots might need to execute rapid, evasive maneuvers while maintaining precise flight paths, situations that could expose the identified weaknesses. She calculated that the response delays could accumulate during complex maneuvers, potentially compromising flight control effectiveness when precision was most critical. Major Thompson was conducting final crew preparations when Riley requested permission to brief the flight crews about her hydraulic system findings. She had prepared detailed analysis showing how the identified anomalies could affect aircraft performance during specific mission phases. The data included recommendations for modified control inputs that could compensate for the system characteristics she had identified. Thompson reviewed her analysis with the patience of an officer accustomed to addressing subordinates' concerns. While maintaining mission schedules, the hydraulic systems had been inspected by qualified technicians and certified for flight operations. The pilots were experienced professionals who understood aircraft limitations and were trained to handle various system malfunctions. Riley's analysis showed impressive technical knowledge, but operational decisions couldn't be modified based on theoretical concerns that weren't supported by standard maintenance criteria. Riley attempted to explain that her analysis wasn't theoretical, but based on measurable system characteristics that became apparent only under specific conditions that matched the mission requirements. She had identified interactions between multiple systems that could create performance degradation exceeding individual component specifications. The cumulative effect could compromise mission effectiveness or crew safety if circumstances required maximum aircraft performance. The institutional response reflected confidence in established procedures and proven experience. Aircraft systems had been designed by teams of engineers and tested under conditions that exceeded normal operational requirements. Pilots were trained to handle system malfunctions and had experience with aircraft performance under various conditions. Mission planning included safety margins and contingency procedures for equipment failures. Riley's concerns, while demonstrating exceptional technical interest, weren't sufficient to justify operational modifications. The pattern continued throughout the afternoon as Riley identified additional anomalies that fell below thresholds for maintenance action but could become significant under mission conditions. Fuel system pressure variations that might affect center of gravity calculations during weapon release. Environmental control inconsistencies that could impact crew performance during extended high-altitude operations. Navigation system drift rates that exceeded specifications under specific electromagnetic conditions. Each concern was addressed through established channels and evaluated according to standard criteria. The responses were professionally courteous, but consistently dismissive. Riley's technical knowledge was acknowledged, but her recommendations weren't incorporated into mission planning or crew briefings. The hierarchy that separated maintenance personnel from operational decision-making remained firmly in place not by 1800 hours. Riley had documented 17 distinct system anomalies that could affect mission performance under the specific conditions planned for the operation. None of these issues met criteria for grounding the aircraft or canceling the mission. Each individual problem was minor enough to be ignored according to standard procedures. However, the cumulative effect of multiple minor issues operating simultaneously under demanding conditions could create a cascade of failures that no single crew member was prepared to handle. Her analysis revealed interdependencies between systems that weren't covered in pilot training or maintenance procedures. The acoustic engine anomaly could be exacerbated by hydraulic response delays during altitude changes. Communication interference could be worsened by fuel system pressure variations that affected antenna positioning. Environmental control inconsistencies could impair crew decision-making when system interactions required Rapid troubleshooting. Riley realized that her comprehensive understanding of aircraft systems and mission requirements had revealed vulnerabilities that were invisible to specialists focused on individual components or procedures. The separation of technical and operational expertise created blind spots where systematic problems could develop without recognition. Her warnings were dismissed not because they were wrong, but because the institutional structure couldn't process information that crossed traditional boundaries between maintenance and operations. The evening crew briefing proceeded according to schedule without incorporating any of Riley's technical findings. Flight crews received standard mission information and routine aircraft status reports. The complex system interactions she had identified remained unknown to the people who would need to respond if multiple anomalies manifested simultaneously during critical mission phases. As darkness settled over Holloman Air Force Base, Riley understood that her expertise would remain unutilized unless circumstances forced recognition of the problems she had identified. The mission would proceed with crews and commanders unaware of the technical vulnerabilities that could transform minor system anomalies into mission-threatening failures. Her role as just a mechanic would continue until events proved that technical knowledge could be more valuable than operational authority. The emergency began at 2147 hours with a message that changed everything in 17 seconds. Captain Morrison was in the medical facility receiving his final pre-mission physical examination when the routine blood work revealed something that should have been detected weeks earlier. His liver enzymes were elevated beyond acceptable levels for high-altitude flight operations, a condition that disqualified him from piloting aircraft above 25,000 feet. The base flight surgeon, Dr. Matthews, reviewed the lab results 3 times before making the call that grounded the mission's primary aircraft commander. Less than 9 hours before scheduled takeoff, Colonel Brennan received the notification while reviewing final intelligence updates in his office. The implications were immediately apparent. Captain Morrison couldn't be replaced by someone with equivalent experience and security clearance on such short notice. Lieutenant Colonel Hayes possessed the technical qualifications to serve as aircraft commander, but she specialized in electronic warfare systems rather than primary flight controls. Her expertise was invaluable for the mission's success, but shifting her to the command position would leave a critical gap in weapons systems management that couldn't be filled by available personnel. The backup crew had been selected based on their combined qualifications rather than individual capabilities. Captain Williams, the backup aircraft commander, was highly experienced in conventional bomber operations, but had limited time in the B-2 cockpit. His most recent stealth bomber training had occurred 18 months earlier, and he hadn't flown night penetration missions through hostile airspace since his deployment to the Middle East 3 years ago. Under normal circumstances, his qualifications would be adequate for routine operations, but this mission demanded expertise that came only from recent, intensive experience with the aircraft's unique characteristics. Major Thompson initiated emergency protocols for crew substitution, contacting personnel assignment offices at 3 different bases to identify qualified pilots who could reach Holloman Air Force Base before the mission launch window closed. The security clearance requirements eliminated most candidates immediately. Those with appropriate clearances were either deployed to other theaters, engaged in critical training exercises, or recovering from recent missions that precluded immediate availability for high-stress operations. The situation deteriorated further at 2,203 hours when Captain Williams reported to the medical facility for his own pre-mission examination. The routine neurological assessment revealed symptoms that suggested the early stages of a vestibular disorder, a condition that could affect spatial orientation. During complex flight maneuvers, Dr. Matthews conducted additional tests that confirmed inner ear dysfunction severe enough to ground Williams from flight duties pending further evaluation. The backup aircraft commander was medically disqualified 16 Minutes after the primary pilot had been removed from flight status, Colonel Brennan convened an emergency meeting in the operations center at 2,230 hours. The assembled personnel included Major Thompson, Captain Rodriguez, Dr. Matthews, and senior representatives from maintenance and security departments. The mission parameters couldn't be modified. Intelligence indicated that the target facility would be relocated within 48 hours, making this the last opportunity to neutralize the threat became operational. Postponing the mission wasn't acceptable given the strategic implications and the resources already committed to the operation. Alternative approaches were evaluated and rejected in rapid succession. Using conventional aircraft would require aerial refueling over hostile territory and accepting casualty rates that exceeded acceptable thresholds. Cruise missile strikes couldn't guarantee complete destruction of hardened underground facilities. Special operations teams couldn't penetrate the target area without air support that wasn't available given current deployment schedules. The B-2 Spirit remained the only viable platform for mission success, but qualified pilots weren't available within the operational timeline. Lieutenant Colonel Hayes volunteered to assume command responsibilities, despite her primary specialization in electronic warfare systems. Her flight hours in the B-2 exceeded minimum requirements for aircraft commander qualification, and her experience with penetrating hostile airspace was extensive. However, her expertise was focused on defensive systems and electronic countermeasures, rather than the primary flight controls and navigation systems that would be critical during the precision approach to the target. Shifting her to the command position would leave the weapons systems operator position unfilled by anyone with comparable qualifications. The weapons systems operator role required intimate knowledge of the B-2's targeting systems, delivery procedures, and electronic warfare capabilities. The position demanded expertise in coordinating multiple attack profiles while managing defensive countermeasures and maintaining communication with command authorities. Available personnel with appropriate security clearances lacked either the technical knowledge or operational experience necessary for the mission's complex requirements. Captain Rodriguez suggested modifying the mission profile to reduce crew workload requirements, potentially allowing Lieutenant Colonel Hayes to manage both aircraft command and weapons systems responsibilities. Analysis revealed that this approach would compromise mission effectiveness while increasing risk factors beyond acceptable parameters. The target's defensive capabilities required coordinated application of electronic warfare measures and precision weapon delivery that couldn't be managed effectively by a single crew member. Dr. Matthews reviewed medical records for all personnel with B-2 qualifications, searching for individuals who might be cleared for emergency flight duty despite minor medical restrictions. The examination revealed that most qualified pilots were either already deployed, recovering from recent medical procedures, or affected by conditions that precluded high-altitude flight operations. The rigorous medical standards for strategic bomber operations had eliminated potential crew members who might be acceptable for routine missions. At 2,256 hours, Major Thompson proposed using pilots from other aircraft types who possessed basic multi-engine qualifications and appropriate security clearances. The suggestion was evaluated by training specialists who calculated that minimum familiarization with B-2 systems would require at least 72 hours of intensive instruction and simulator training. The mission launch window would close in less than 8 hours, making adequate preparation impossible even under emergency training protocols. The communications center received updates from personnel offices confirming that no qualified pilots could reach Holloman Air Force Base within the required time frame. Commercial aviation schedules, military transport availability, and geographical constraints created a situation where external resources couldn't address the crew shortage. The mission appeared to be approaching cancellation due to personnel limitations rather than technical or operational factors, Colonel Brennan authorized exploration of unprecedented alternatives. The suggestion emerged to utilize instructor pilots from the training command who possessed extensive B-2 experience but hadn't maintained current qualifications for combat operations. Investigation revealed that these individuals were either retired from active duty, assigned to positions that precluded immediate deployment, or located at facilities that couldn't provide transportation within the available timeline. Emergency protocols were expanded to include pilots from allied nations who had received B-2 training through cooperative programs. Security clearance verification and diplomatic coordination requirements made this option impractical given the classified nature of the mission and the compressed timeline. International agreements governing access to strategic weapons systems included restrictions that couldn't be waived without authorization from the highest levels of government. At 2,334 hours, the situation reached a critical decision point. Lieutenant Colonel Hayes could potentially manage both aircraft command and weapons systems responsibilities, but mission success probability would be significantly reduced. The alternative was mission cancellation with strategic implications that extended far beyond the immediate tactical objectives. Intelligence assessments confirmed that the target facility represented a genuine threat to regional stability, and this opportunity for neutralization might not occur again. The medical officers were consulted about the possibility of clearing Captain Morrison or Captain Williams for limited flight duty with appropriate medications and monitoring. Dr. Matthews explained that the liver enzyme elevation in Morrison's case indicated systemic stress that could be exacerbated by high altitude operations and combat stress. Williams' vestibular disorder could cause disorientation during critical flight phases when precise aircraft control was essential. Neither condition could be safely managed during a demanding combat mission. Technical specialists evaluated the possibility of modifying aircraft systems to reduce crew workload requirements through automated procedures or simplified operational modes. The analysis revealed that the mission's requirements for stealth penetration, precision navigation, and coordinated weapons delivery demanded manual control and real-time decision-making that couldn't be effectively automated. The B-2's sophisticated systems required experienced operators who understood the complex interactions between multiple subsystems. At 2,347 hours, Colonel Brennan made the decision that would define the next several hours. The mission would proceed with Lieutenant Colonel Hayes as aircraft commander and an unprecedented search for someone who could manage weapons systems operations. The search parameters were expanded beyond traditional pilot qualifications to include anyone with comprehensive knowledge of B-2 systems and the technical capability to operate complex military equipment under combat conditions. The operations center became a focal point for frantic coordination as personnel officers reviewed records of everyone on the base with appropriate security clearances and technical qualifications. Maintenance supervisors were consulted about technicians who had demonstrated exceptional knowledge of aircraft systems. Training instructors were contacted about individuals who had shown unusual aptitude for complex procedures. The search expanded to include personnel whose official duties didn't encompass flight operations, but whose expertise might translate to operational requirements. Flight crews from other aircraft types were evaluated for potential cross-training into B-2 operations. The assessment revealed that fundamental differences in aircraft design and operational procedures made rapid transition impossible. Navigation specialists, bombardiers, and electronic warfare officers from conventional aircraft lacked the integrated system knowledge necessary for stealth bomber operations. Their expertise was valuable but couldn't be adapted to B-2 requirements within the available timeline. At 0012 hours, the reality became apparent that traditional solutions weren't available within the operational constraints. The mission faced Cancellation unless someone could be identified who possessed the technical knowledge and operational understanding necessary to function as weapons systems operator. The search had exhausted conventional alternatives and was approaching territory where unprecedented decisions would be required. The crisis had evolved from a medical disqualification to a fundamental challenge of personnel availability and institutional limitations. Standard procedures and established hierarchies couldn't address a situation that required expertise existing outside traditional operational boundaries. The mission's success would depend on finding someone whose qualifications transcended conventional categories and whose capabilities could bridge the gap between technical knowledge and operational requirements. In the maintenance hangar, Riley continued her routine preparations for aircraft launch, unaware that the mission's survival depended on finding someone with exactly the combination of technical expertise and operational understanding that she had developed through years of unofficial study and comprehensive system analysis. The crisis was about to reveal whether institutional flexibility could overcome hierarchical limitations when strategic objectives hung in the balance. The call came at 0034 hours through the maintenance hangar's emergency communication system. Riley was conducting final systems verification on Ghostwriter when Technical Sergeant Williams' voice crackled through the overhead speakers with unusual urgency. All maintenance personnel with secret clearance or higher were to report immediately to the operations center for emergency briefing. The tone suggested something far beyond routine mission changes or equipment malfunctions. Riley secured her diagnostic equipment and made the 3-minute walk to the operations building, her mind cataloging the various scenarios that could require maintenance personnel at operational briefings. The hallways buzzed with activity unusual for the early morning hours. Security personnel moved with heightened alertness. Communications specialists manned stations that normally operated with skeleton crews, and officers who should have been sleeping before the mission deadline moved with the controlled urgency of crisis management. The operations center had been transformed into something resembling a war room. Digital displays showed aircraft status, weather patterns, and classified information that Riley had never seen during routine briefings. Colonel Brennan stood at the center of the activity, his uniform bearing the wrinkled evidence of an unexpectedly long night. Major Thompson coordinated with multiple communication stations while Captain Rodriguez updated intelligence assessments in real time. The atmosphere carried the electric tension of people making decisions with strategic implications. Lieutenant Colonel Hayes stood beside the primary mission display, her flight suit already prepared for operations that were scheduled to begin in less than 5 hours. Her expression showed the focused concentration of someone accepting responsibilities beyond normal parameters. Riley noticed that the backup crew positions remained conspicuously empty, a detail that suggested complications in personnel assignments that extended beyond routine adjustments. Colonel Brennan addressed the assembled maintenance personnel with uncharacteristic directness. The mission faced potential cancellation due to medical disqualifications that had eliminated both primary and backup aircraft commanders. Lieutenant Colonel Hayes would assume command responsibilities, but the weapons systems operator position remained unfilled. Traditional solutions had been exhausted, and unconventional alternatives were being evaluated to preserve mission viability. The requirements for the weapons systems operator role were explained in detail that revealed the complexity of B-2 operations. The position demanded comprehensive knowledge of targeting systems, electronic warfare capabilities, navigation procedures, and communication protocols. The operator would coordinate weapon delivery while managing defensive countermeasures and maintaining situational awareness of multiple threat systems. The role required someone who could function effectively under combat stress, while making split-second decisions that could determine mission success or failure. Riley listened with growing understanding that her years of unofficial study had prepared her for exactly this situation. Her comprehensive knowledge of B-2 systems extended far beyond maintenance procedures to include operational capabilities that most technicians never encountered. Her analysis of mission requirements and aircraft limitations had given her insights into the integration of multiple systems during complex operations. Her simulator experience, while unofficial, had provided hands-on familiarity with procedures that paralleled the described requirements. Major Thompson explained that the search for qualified personnel had expanded beyond traditional pilot categories to include anyone with appropriate security clearances and demonstrated technical expertise. Maintenance personnel with exceptional system knowledge were being evaluated for potential assignment to operational roles. The unprecedented nature of the situation required creative solutions that transcended normal organizational boundaries. The briefing continued with detailed explanation of the mission parameters that would challenge even experienced crews. The target was located deep within hostile territory protected by sophisticated air defense systems. The approach required precise navigation through multiple threat zones while maintaining stealth characteristics and coordinating with electronic warfare assets. The weapon delivery demanded split-second timing and accuracy that left no margin for error. Riley realized that her technical knowledge encompassed every aspect of the described requirements. Her understanding of stealth technology could guide tactical decisions about radar cross-section management. Her expertise in electronic systems could enable effective operation of countermeasures equipment. Her analysis of aircraft performance characteristics could inform navigation decisions during critical mission phases. Her weapons systems knowledge could ensure accurate target engagement and successful weapon delivery. When Colonel Brennan asked for volunteers with relevant technical expertise, Riley stepped forward without hesitation. Her action surprised the assembled maintenance personnel, who had never seen her volunteer for duties beyond assigned responsibilities. Technical Sergeant Williams looked skeptical about her presumption in volunteering for operational roles, typically reserved for commissioned officers and trained aircrew. Riley's volunteer statement was delivered with quiet confidence that reflected her comprehensive preparation rather than ambitious overreach. She explained her technical qualifications systematically, beginning with her official maintenance credentials and expanding to describe her unofficial study of operational procedures. Her knowledge of B-2 systems exceeded normal maintenance requirements and included detailed understanding of tactical employment and mission planning procedures. The response from senior officers was initially skeptical, but her technical explanations demonstrated knowledge that surprised experienced pilots and operations specialists. When questioned about specific systems, Riley provided detailed answers that revealed understanding of complex interactions between multiple aircraft components. Her insights into potential failure modes and contingency procedures showed analytical capabilities that exceeded routine technical training. Lieutenant Colonel Hayes conducted an impromptu technical interview that tested Riley's knowledge across multiple operational areas. Questions about navigation procedures, targeting systems, and electronic warfare capabilities were answered with precision that indicated genuine expertise rather than superficial familiarity. Riley's responses included details about system limitations and operational considerations that weren't covered in standard technical manuals. The evaluation process intensified as senior officers recognized that Riley possessed qualifications that weren't reflected in her official personnel records. Her understanding of mission requirements and aircraft capabilities demonstrated preparation that went far beyond normal duty assignments. Her analysis of potential complications showed strategic thinking that complemented her technical expertise. Captain Rodriguez tested Riley's knowledge of threat systems and defensive procedures, areas that required understanding of enemy capabilities and friendly countermeasures. Riley's responses indicated study of intelligence, assessments and tactical procedures that maintenance personnel weren't normally authorized to access. Her insights into electronic warfare interactions showed comprehensive understanding of the electromagnetic environment that the mission would encounter. Major Thompson evaluated Rayleigh's understanding of mission planning and coordination procedures, testing her knowledge of communication protocols and command relationships during complex operations. Rayleigh demonstrated familiarity with operational procedures that indicated extensive study of subjects outside her official responsibilities. Her grasp of timing requirements and contingency planning showed preparation for scenarios that extended beyond routine maintenance activities. The technical evaluation revealed that Rayleigh possessed the most comprehensive understanding of B-2 systems and mission requirements of anyone available within the operational timeline. Her knowledge bridged the gap between technical expertise and operational requirements in ways that traditional training categories hadn't achieved. Her preparation had created qualifications that exactly matched the mission's unprecedented personnel needs. Colonel Brennan made the decision that would define the next several hours and potentially alter the course of strategic operations. Rayleigh would be assigned as weapons systems operator for the mission, with Lieutenant Colonel Hayes providing operational guidance and command authority. The assignment was unprecedented in its departure from normal personnel policies, but the strategic importance of the mission justified extraordinary measures. The rapid transition from maintenance technician to combat aircrew member required immediate intensive preparation. Rayleigh was briefed on mission-specific procedures, communication protocols, and contingency plans that weren't covered in her unofficial studies. The compressed timeline demanded rapid assimilation of information that normally required weeks of formal training. Flight gear was hastily modified to accommodate Rayleigh's assignment to the weapons systems operator position. Her security clearance was elevated through emergency procedures that compressed normal verification timelines into hours rather than weeks. Medical clearance was expedited through abbreviated examinations that focused on essential requirements for high-altitude flight operations. The aircraft preparation procedures were modified to accommodate Rayleigh's transition from maintenance oversight to operational crew member. Systems that she had maintained for years would now be operated under combat conditions with responsibility for mission success and crew safety. Her technical knowledge of these systems would be applied in ways that her training had never anticipated. As 300 hours approached, Rayleigh found herself in the unprecedented position of preparing for combat operations as a crew member of the aircraft she had maintained with such dedication. Her years of unofficial study and comprehensive system analysis had qualified her for responsibilities that no formal training program could have provided. The mission that had faced cancellation due to personnel limitations would proceed because someone had recognized that expertise could transcend traditional organizational boundaries. The transformation from just a mechanic to essential crew member was complete, but the ultimate test would come during the mission itself. Rayleigh's technical knowledge and operational understanding would be evaluated under combat conditions where theoretical preparation would meet the reality of strategic operations over hostile territory. The moment of truth had arrived, and everything depended on whether her comprehensive preparation could translate into successful performance. When failure meant more than mission objectives, it meant the safety of aircrew and the success of operations critical to national security. The final preparations began with Rayleigh taking her position in the weapons systems operator station, surrounded by displays and controls that she understood better than most people who had trained specifically for this role. Her years of invisible preparation were about to become visible in the most dramatic way possible. The mission launch occurred at 0530 hours, under a moonless sky that provided natural concealment for the most classified aircraft in the American arsenal. Ghost Rider lifted off from Holloman Air Force Base with Lieutenant Colonel Hayes at the primary controls and Rayleigh Shun occupying the weapons systems operator station that she had studied for years but never officially operated. The takeoff proceeded smoothly despite the unprecedented crew configuration, with Riley's technical knowledge translating seamlessly into operational procedures she had rehearsed countless times in simulation. The first test of Riley's capabilities came during the initial navigation phase as Ghost Rider climbed toward its cruising altitude of 50,000 feet. The flight management system experienced intermittent data corruption that caused navigation errors requiring manual correction. Lieutenant Colonel Hayes focused on maintaining aircraft control, while Riley diagnosed the electronic interference that was causing the navigation anomalies. Her analysis revealed that the problem originated from electromagnetic interference between the satellite communication array and the inertial navigation system, precisely the interaction she had identified during pre-mission testing. Riley's solution involved reconfiguring the communication protocols to operate on alternate frequencies that wouldn't interfere with navigation sensors. The procedure wasn't covered in standard operating manuals because the specific interference pattern had never been documented during normal operations. Her knowledge of system interactions enabled rapid identification and correction of the problem without compromising mission timeline or alerting ground controllers to technical difficulties that could have justified mission termination. Lieutenant Colonel Hayes observed Riley's troubleshooting process with growing respect for her technical expertise and calm demeanor under pressure. The navigation problem would have challenged experienced electronic specialists, but Riley resolved it with efficiency that demonstrated comprehensive understanding of complex system interactions. Her ability to maintain situational awareness while managing multiple technical issues showed operational maturity that contradicted her official status as maintenance personnel. The second major challenge emerged during the first aerial refueling rendezvous over the Pacific Ocean. The refueling receptacle, EXP, ERIENCED, hydraulic pressure fluctuations that prevented proper connection with the tanker aircraft's refueling boom. Standard procedures called for aborting the refueling attempt and returning to base, a decision that would have terminated the mission due to insufficient fuel for the complete flight profile. Riley recognized the hydraulic anomaly as the same intermittent problem she had identified during pre-mission inspections. Her analysis of the hydraulic system revealed that the pressure fluctuations occurred only during specific aircraft attitudes that combined altitude, airspeed, and control surface positions in ways that created resonance in the hydraulic lines. By calculating the precise flight parameters that would minimize the resonance effect, Riley provided Lieutenant Colonel Hayes with control inputs that stabilized the hydraulic pressure long enough to complete the refueling connection. The successful refueling was accomplished through a combination of precise aircraft handling by Lieutenant Colonel Hayes and real-time system analysis by Riley that enabled them to work around technical limitations that would have defeated less knowledgeable crew members. The tanker aircraft crew observed the unusual maneuvering required for connection but remained unaware of the technical problem that could have compromised the entire mission. Riley's solution preserved operational security while ensuring mission continuation. As Ghost Rider approached hostile airspace, the electronic warfare environment became increasingly complex. Enemy radar systems probed the electromagnetic spectrum with sophisticated detection algorithms designed to identify stealth aircraft through advanced signal processing techniques. Riley monitored the defensive systems with intensity that revealed her comprehensive understanding of electronic warfare principles and threat assessment procedures. The aircraft's radar warning receiver detected multiple threat emissions that indicated a coordinated air defense network more sophisticated than intelligence assessments had predicted. Standard defensive procedures called for specific countermeasures that Riley realized would be insufficient against the detected threat configuration. Her analysis of the electromagnetic signatures revealed enemy capabilities that exceeded the mission planning assumptions about hostile defensive systems. Riley implemented advanced countermeasures that weren't part of standard procedures but were available through the aircraft's experimental electronic warfare suite. Her knowledge of the system's undocumented capabilities enabled deployment of defensive measures that created false radar signatures while masking Ghost Rider's actual location. The countermeasures were successful in deceiving enemy tracking systems, but their effectiveness depended on precise timing and coordination that required real-time analysis of threat emissions. Lieutenant Colonel Hayes maintained aircraft control through the hostile airspace while Riley managed the electronic warfare battle that was invisible to everyone except the crew members who understood the sophisticated technologies involved. The defensive engagement required split-second decisions about countermeasure employment and threat prioritization that tested Riley's ability to apply theoretical knowledge under combat conditions where mistakes could result in aircraft loss and crew casualties. The approach to the target area revealed additional complications that hadn't been anticipated during mission planning. The facility was protected by mobile surface-to-air missile systems that had been repositioned since the King last intelligence update. The new defensive configuration created engagement zones that overlapped in ways that eliminated the planned attack corridor and required real-time modification of the weapon delivery profile. Riley analyzed the threat geometry while calculating alternative approach vectors that could minimize exposure to enemy defensive systems. Her understanding of both weapon delivery requirements and aircraft performance limitations enabled development of a modified attack profile that preserved mission effectiveness while reducing risk to acceptable levels. The solution required precise coordination between aircraft maneuvering and weapon release timing that pushed both crew members to the limits of their capabilities. The weapon delivery phase demanded integration of navigation, targeting, and electronic warfare systems in a coordinated sequence that Riley had studied extensively but never performed under actual combat conditions. Her knowledge of system interactions enabled her to manage multiple simultaneous processes while maintaining situational awareness of the tactical environment. The successful weapon release was accomplished through teamwork between Lieutenant Colonel Hayes and Riley that demonstrated exceptional crew coordination despite their limited experience working together. The weapons struck their targets with precision that exceeded mission planning expectations, neutralizing the research facility completely while minimizing collateral damage to surrounding areas. The successful attack was confirmed through real-time damage assessment that showed complete destruction of the intended targets. Riley's contribution to mission success extended beyond technical system operation to include tactical analysis and problem-solving that had been essential for overcoming unexpected challenges. The egress from hostile territory required continued management of electronic warfare systems while navigating through air defense networks that had been alerted by the successful attack. Riley maintained defensive countermeasures while monitoring enemy interceptor aircraft that might attempt to track Ghost Rider during its withdrawal from the target area. Her vigilance and technical expertise ensured that the aircraft remained undetected during the most vulnerable phase of the mission. The second aerial refueling was accomplished without the hydraulic problems that had complicated the earlier connection, partly because Riley had identified additional system modifications that improved pressure stability during refueling operations. Her ongoing analysis of aircraft systems enabled continuous optimization of performance throughout the mission, demonstrating that her technical knowledge could enhance operations even beyond the immediate requirements of her assigned duties. Return flight to Holloman Air Force Base provided time for Lieutenant Colonel Hayes and Riley to reflect on their performance during the mission. Hayes expressed genuine amazement at Riley's technical capabilities and operational effectiveness, acknowledging that the mission's success had depended significantly on expertise that existed outside traditional crew training programs. Riley's contributions had been essential not just for completing assigned tasks, but for solving problems that could have resulted in mission failure. Ground controllers at Holloman received position reports that indicated normal mission progress without any indication of the technical challenges that had been overcome through exceptional crew performance. The successful completion of the mission was apparent from navigation data and communication reports, but the full extent of Riley's contributions remained known only to the crew members who had witnessed her performance firsthand. Ghostwriter touched down at Holloman Air Force Base at 1347. Hours after completing one of the most successful strategic bombing missions in recent military history. The landing was smooth and precise, reflecting the professional competence of Lieutenant Colonel Hayes and the technical support provided by Riley throughout the demanding flight operations. The aircraft taxied to its designated parking position, with all systems functioning normally, showing no evidence of the complex technical problems that had been resolved during the mission. As the engines shut down and the aircraft systems powered off, Lieutenant Colonel Hayes turned to Riley with an expression that combined respect, gratitude, and genuine amazement. The mission had required technical expertise and operational judgment that transcended traditional organizational boundaries, and Riley's performance had demonstrated capabilities that challenged fundamental assumptions about the relationship between formal training and actual competence. The immediate recognition of Riley's exceptional performance began before the crew had even exited the aircraft. Lieutenant Colonel Hayes' post-mission report would document technical innovations and problem-solving achievements that established new standards for crew performance under demanding conditions. Riley's transformation from maintenance technician to essential crew member had been validated through mission success that couldn't have been achieved without her unique combination of technical knowledge and operational capability. The mission's success represented more than the achievement of tactical objectives. It demonstrated that expertise could transcend institutional categories when strategic requirements demanded unprecedented solutions. Riley's performance had proven that comprehensive preparation and technical mastery could enable individuals to contribute at levels that formal qualifications alone couldn't predict or measure. The debriefing room at Holloman Air Force Base had never hosted a session quite like the one that began at 1500 hours on October 16th. Colonel Brennan sat at the head of the polished conference table, surrounded by intelligence analysts, operations specialists, and senior officers who had spent the morning reviewing preliminary reports that challenged their understanding of personnel capabilities and mission execution. The successful completion of the most classified operation in recent military history had been achieved through crew performance that defied conventional categorization. Lieutenant Colonel Hayes presented her post-mission report with the precision of an experienced officer who understood that her words would be analyzed by superiors seeking to understand how an unprecedented personnel decision had resulted in exceptional mission success. Her technical description of system malfunctions and innovative solutions revealed the extent to which Riley's expertise had been essential for overcoming challenges that could have resulted in mission failure or aircraft loss. The navigation system interference that Riley had diagnosed and corrected during the initial climb had never been documented in official technical manuals. Her identification of electromagnetic interactions between communication and navigation systems represented original analysis that would require formal study by aircraft manufacturers and military technical specialists. The solution she had implemented demonstrated theoretical understanding, combined with practical application that exceeded the capabilities of most electronic specialists. Captain Rodriguez reviewed intelligence assessments that confirmed the mission's strategic success while highlighting tactical adaptations that had been necessary during execution. The real-time threat analysis and modified attack profile that Riley had developed showed integration of technical knowledge with operational judgment that traditionally required years of specialized training. Her ability to process complex tactical information while managing sophisticated weapons systems had enabled mission success under conditions that exceeded planning assumptions. Major Thompson analyzed crew performance metrics that revealed coordination between Lieutenant Colonel Hayes and Riley that exceeded standard benchmarks for experienced crews who had trained together for months. Their ability to function effectively as an integrated team, despite minimal prior experience working together, demonstrated exceptional individual capabilities and professional adaptability. The mission had required decision-making and problem-solving that challenged both crew members to perform beyond their established qualifications. Dr. Matthews provided medical assessments that confirmed both crew members had maintained optimal performance throughout the demanding flight operations. The physiological stress data showed that Riley had adapted to high-altitude flight conditions and combat environments without experiencing degradation in cognitive function or technical performance. Her transition from ground-based maintenance duties to aircrew responsibilities had been accomplished without medical complications that might have compromised mission effectiveness. The formal recognition process began immediately following the debriefing session. Colonel Brennan authorized emergency promotion procedures that advanced Riley from Staff Sergeant to Technical Sergeant, acknowledging her contributions to mission success while establishing precedent for recognizing exceptional performance that transcended traditional organizational boundaries. The promotion was unprecedented in its rapid implementation and its basis on operational achievement rather than routine career progression. Security classification procedures were modified to accommodate Riley's new status as someone whose operational knowledge encompassed the most sensitive aspects of strategic weapons employment. Her security clearance was elevated to levels normally reserved for senior officers and specialized personnel whose duties required access to information affecting national security. The clearance modification recognized that her technical expertise and operational experience had created qualifications that demanded appropriate authorization levels. Training Command initiated comprehensive analysis of Riley's unofficial education program to identify methods that could be incorporated into formal aircrew preparation procedures. Her systematic study of aircraft systems, operational procedures, and tactical employment had achieved results that conventional training programs hadn't matched. The analysis revealed gaps in standard education that could be addressed through modified curricula that emphasized integration of technical knowledge with operational requirements. The impact of Riley's performance extended beyond individual recognition to influence institutional policies about personnel utilization and capability. Assessment. Traditional boundaries between maintenance and operations were examined to identify other situations where technical expertise might enhance operational effectiveness. Her success demonstrated that comprehensive system knowledge could translate into aircrew capabilities when individuals possessed appropriate analytical skills and operational understanding. Flight training programs began incorporating technical education that had previously been considered beyond the scope of pilot preparation. Riley's demonstration that detailed system knowledge could enhance operational performance led to curriculum modifications that required aircrew to understand aircraft systems at levels approaching maintenance specialist qualifications. The changes reflected recognition that technical expertise could improve decision-making and problem-solving during complex missions. Maintenance training evolved to include operational perspectives that help technicians understand how their work affected mission performance and aircrew effectiveness. Riley's transition from maintenance to operations had been facilitated by her comprehensive understanding of how aircraft systems functioned during actual flight operations. The insight led to training modifications that gave maintenance personnel exposure to operational requirements and tactical considerations. The weapons systems operator career field was expanded to include pathways for exceptional maintenance personnel who demonstrated aptitude for operational duties. Rayleigh's success had proven that technical expertise could provide foundation for aircrew qualifications when combined with appropriate operational training. The career field modifications created opportunities for individuals whose capabilities transcended traditional organizational categories. Advanced technical training programs were established to identify and develop personnel who showed potential for bridging technical and operational domains. The programs emphasized comprehensive system understanding combined with analytical skills that could enable innovative problem-solving during complex operations. Rayleigh's example provided a template for developing individuals who could contribute at levels that formal qualifications alone couldn't predict. Research initiatives were launched to study the relationship between technical expertise and operational effectiveness in complex military systems. Rayleigh's performance had demonstrated correlations between detailed system knowledge and mission success that warranted systematic investigation. The research programs aimed to identify methods for optimizing personnel capabilities across traditional organizational boundaries. International military exchange programs began including technical specialists who could provide insights into advanced weapon systems and operational procedures. Rayleigh's demonstration that technical knowledge could translate into operational capabilities influenced collaborative programs with allied nations, whose personnel might benefit from similar cross-functional training approaches. The exchanges reflected recognition that technical expertise represented strategic assets that could enhance international cooperation. The B-2 Program Office initiated a comprehensive review of crew training standards to incorporate lessons learned from Rayleigh's exceptional performance. Her ability to operate sophisticated systems without traditional aircrew preparation suggested that conventional training assumptions might be limiting optimal crew utilization. The review aimed to identify methods for maximizing the capabilities of available personnel while maintaining safety and effectiveness standards. Simulator training protocols were modified to include scenarios that tested integration of technical knowledge with operational judgment. Rayleigh's success had demonstrated that comprehensive system understanding could enable innovative solutions to problems that conventional training hadn't addressed. The simulator modifications provided opportunities for personnel to develop analytical skills that could enhance performance during unexpected situations. Emergency response procedures were updated to include utilization of technical specialists who might possess capabilities relevant to operational situations. Rayleigh's transition from maintenance to aircrew duties had established precedent for non-traditional personnel assignments when circumstances required exceptional expertise. The procedures created frameworks for identifying and utilizing specialized knowledge during crisis situations. Professional military education curricula incorporated case studies based on Rayleigh's performance to illustrate principles of leadership, innovation, and adaptability under challenging conditions. Her success demonstrated that preparation and competence could transcend formal qualifications when strategic requirements demanded innovative solutions. The case studies provided examples of how individual initiative and comprehensive preparation could contribute to mission success. Recognition programs were established to identify personnel whose unofficial education and exceptional preparation might qualify them for expanded responsibilities. Rayleigh's systematic study of subjects beyond her assigned duties had created capabilities that proved essential for mission success. The programs aimed to identify others whose initiative and comprehensive knowledge could enhance organizational effectiveness. Technical innovation initiatives were launched to capture and formalize the analytical methods that Rayleigh had developed through independent study. Her ability to diagnose complex system interactions and develop innovative solutions represented intellectual capital that could benefit broader military applications. The initiatives aimed to systematize her analytical approaches for use by other technical specialists. Cross-functional team assignments became standard, Practice for complex missions that required integration of technical and operational expertise. Riley's successful collaboration with Lieutenant Colonel Hayes had demonstrated that diverse backgrounds and complementary skills could enhance overall crew effectiveness. The team assignments recognized that mission success often depended on capabilities that no single individual possessed completely. Long-term career development programs were created to nurture individuals who showed potential for exceptional contributions across traditional organizational boundaries. Riley's example demonstrated that comprehensive preparation and technical mastery could enable contributions at levels that exceeded formal position requirements. The programs provided pathways for developing such capabilities systematically rather than depending on individual initiative alone. The lasting impact of Riley's achievement extended far beyond the immediate success of a single mission. Her transformation from just a mechanic to essential aircrew member had demonstrated that expertise and preparation could overcome institutional limitations when strategic objectives required innovative solutions. The recognition of her capabilities had initiated changes in training, career development, and personnel utilization that would influence military operations for years to come. Her legacy was not measured in medals or promotions but in the institutional changes that created opportunities for others whose capabilities transcended traditional categories. The barriers between technical and operational domains had been lowered because one person had proven that comprehensive knowledge and exceptional preparation could bridge gaps that organizational structures had assumed were permanent. Riley continued her duties with the same dedication and attention to detail that had characterized her work before achieving recognition for operational capabilities. The difference was that her expertise was now acknowledged and utilized at appropriate levels, rather than dismissed as beyond her official responsibilities. She had become proof that excellence could emerge from unexpected sources when individuals committed themselves to comprehensive preparation and institutional flexibility allowed merit to overcome traditional limitations. The mission's success had validated the principle that readiness and competence could create opportunities that formal qualifications alone might never provide. Riley's story became evidence that preparation in silence could lead to recognition. When circumstances demanded capabilities that transcended conventional expectations, her achievement demonstrated that being ready when called upon was more valuable than any credential or official designation could provide. 5 years after the classified mission that changed everything, Riley's influence had permeated every level of military aviation. The Chun Protocol became the official designation for emergency crew substitution procedures that utilized technical specialists with demonstrated operational knowledge. Air Force bases worldwide implemented the protocol, creating rapid assessment systems for identifying personnel whose unofficial expertise might qualify them for expanded responsibilities during crisis situations. The Strategic Air Command established the Technical Excellence Center at Holloman Air Force Base, with Riley serving as its first director. The center's mission focused on developing personnel who could bridge technical and operational domains, creating a new category of military specialists whose capabilities transcended traditional organizational boundaries. The center's graduates were deployed to critical assignments worldwide, where their integrated expertise enhanced mission effectiveness and operational flexibility. Advanced simulation facilities were constructed to replicate the complex decision-making scenarios that Riley had navigated during her transition from maintenance to operations. These facilities became testing grounds for personnel whose potential exceeded their formal qualifications, providing controlled environments where exceptional capabilities could be identified and developed. The simulation programs produced graduates who became leaders in technical innovation and operational excellence across multiple military branches. Congressional testimony by senior military leaders cited Riley's performance as evidence for expanded funding of cross-functional training programs and Technical education initiatives. Her success had demonstrated measurable returns on investment in comprehensive personnel development that justified significant budget allocations for innovative training approaches. The testimony influenced defense appropriations that supported fundamental changes in military education and career development systems. International military academies incorporated Riley's story into leadership curricula that emphasized the importance of recognizing and utilizing exceptional talent, regardless of traditional hierarchical limitations. Her example became required study for officer candidates, who would be responsible for making personnel decisions that could affect mission outcomes. The education emphasized that leadership involved identifying and empowering capabilities that might exist outside conventional expectations. Defense contractor training programs were modified to include technical specialists who could provide insights into operational requirements and system integration challenges. Riley's demonstration that comprehensive technical knowledge could enhance operational effectiveness influenced industry approaches to personnel development and project management. The modifications improved communication between technical teams and operational users, resulting in more effective weapon systems and support equipment. Research. Universities established fellowship programs that brought military technical specialists into academic environments, where they could pursue advanced degrees while contributing operational perspectives to theoretical research. Riley's combination of practical experience and analytical capability provided a model for integrating military expertise with academic investigation. The programs produced research that bridged theoretical knowledge with practical application in ways that benefited both military operations and scientific advancement. The Riley Chun Institute for Technical Leadership was founded at the Air Force Institute of Technology, focusing on developing personnel who could lead complex technical organizations while understanding operational requirements. The Institute's curriculum emphasized systems thinking, analytical problem solving, and the integration of technical expertise with strategic decision-making. Graduates of the program became leaders in defense technology development and military innovation initiatives. Professional conferences began featuring technical specialists alongside operational commanders as keynote speakers, recognizing that comprehensive understanding of complex systems required both technical depth and operational breadth. Riley's presentations at these conferences became legendary for their integration of detailed technical analysis with strategic insights. Her speaking engagements influenced defense policy and procurement decisions at the highest levels of government. Military medical research expanded to study the physiological and psychological factors that enabled successful transitions between technical and operational roles. Riley's adaptation to aircrew responsibilities despite limited traditional training provided valuable data about human performance under challenging conditions. The research contributed to improved selection criteria and training methods for personnel assigned to demanding military specialties. The success of personnel who followed pathways inspired by Riley's example created a growing community of technical specialists who had achieved operational recognition. This community became a source of innovation and problem-solving that enhanced military capabilities across diverse mission areas. Regular conferences and professional organizations developed to support this community and share best practices for maximizing individual contributions to organizational effectiveness. At corporate leadership development programs in the defense industry began emphasizing technical competence as a foundation for executive responsibility. Riley's demonstration that comprehensive system knowledge could inform strategic decision-making influenced hiring and promotion practices throughout the defense sector. The emphasis on technical leadership created more effective communication between engineering teams and business leadership, improving product development and customer satisfaction. Military historians documented Riley's achievement as a pivotal moment in the evolution of military personnel management, comparable to other breakthrough instances where individual performance had challenged institutional assumptions. Her story became part of the historical record that illustrated how exceptional individuals could influence organizational development and strategic capability. The documentation ensured that her example would inform future generations of military leaders and policymakers. Educational documentaries and training films used Riley's story to illustrate principles of excellence, preparation, and institutional adaptability. These materials were used in leadership training programs throughout the military and in civilian organizations that face similar challenges in recognizing and utilizing exceptional talent. The widespread distribution of her story influenced management practices and organizational culture far beyond military applications. The annual Riley Chun Award for Technical Excellence became the military's most prestigious recognition for personnel whose unofficial education and exceptional preparation had contributed to mission success. Recipients of the award were selected based on criteria that emphasized comprehensive system knowledge, innovative problem-solving, and the ability to transcend traditional role limitations. The award created incentives for personnel to pursue excellence beyond minimum requirements and encouraged supervisors to recognize exceptional capabilities, regardless of formal qualifications. Years later, when asked about the factors that had enabled her transition from maintenance technician to essential aircrew member, Riley consistently emphasized preparation, curiosity, and the willingness to study subjects that extended beyond immediate job requirements. She credited her success to institutional leaders who were willing to recognize capability when circumstances demanded innovative solutions. Her humility about personal achievement, combined with advocacy for systemic changes that would create opportunities for others, became characteristic of her public presentations and professional interactions. The enduring impact of Riley's achievement was measured not in individual recognition but in the systemic changes that created pathways for others whose potential might otherwise remain unutilized. Her legacy lived in every technical specialist who was given opportunity to contribute at operational levels, every training program that emphasized comprehensive system understanding, and every institutional policy that valued competence over conventional qualifications. The transformation from just a mechanic to pioneering technical leader had demonstrated that preparation combined with opportunity could overcome any limitation that institutions might impose on individual potential. Riley's story proved that excellence could emerge from unexpected sources when organizations were flexible enough to recognize merit and individuals were dedicated enough to develop capabilities that exceeded their assigned responsibilities. Her example continued to inspire personnel who worked quietly to develop expertise that went beyond their official duties, knowing that comprehensive preparation could create opportunities that formal qualifications alone might never provide. The lesson of her achievement was simple but profound. Readiness combined with competence could overcome any barrier when circumstances demanded capabilities that transcended traditional expectations and limitations. The technological revolution that followed Riley's mission success transformed how military systems were designed and operated. Defense contractors began developing aircraft with integrated diagnostic systems that could be operated by technically trained personnel without traditional pilot qualifications. These innovations were directly inspired by Riley's demonstration that comprehensive system knowledge could enable effective operation of complex equipment. The new designs incorporated user interfaces that leveraged technical expertise while maintaining operational effectiveness. Advanced artificial intelligence systems were developed to identify personnel whose skill sets and knowledge bases might qualify them for expanded responsibilities. These systems analyzed training records, educational achievements, and performance evaluations to predict which individuals might succeed in roles outside their traditional career fields. The AI algorithms were trained using data from Riley's case and similar examples of successful cross-functional transitions, creating predictive models that helped identify hidden talent throughout the military. The Global Technical Exchange Program was established to share Riley's training methodologies with allied nations, facing similar challenges in maximizing personnel capabilities. Military attaches from dozens of countries visited Holloman Air Force Base to study the programs that had been developed based on her example. The international cooperation led to standardized approaches for identifying and developing technical specialists who could contribute to operational missions across different military organizations. Space Force personnel management was fundamentally influenced by Riley's example when the new service branch was established. The unique requirements of space operations demanded personnel who could bridge technical and operational domains, similar to Riley's combination of maintenance expertise and operational capability. The Space Force career fields were designed from inception to accommodate individuals whose capabilities transcended traditional boundaries, creating opportunities for technical specialists to assume operational responsibilities. Corporate defense contractors established Riley teams, consisting of technical specialists who worked directly with operational users to identify system improvements and operational enhancements. These teams were empowered to make recommendations that influenced design decisions and procurement specifications. The approach recognized that technical expertise combined with operational understanding could improve weapon systems' effectiveness and user satisfaction in ways that traditional development processes had missed. The military medical corps expanded psychological evaluation procedures to identify personnel who might possess the analytical capabilities and stress tolerance necessary for successful transitions between technical and operational roles. Riley's medical data from her mission provided baseline measurements for developing selection criteria that could predict successful adaptation to demanding operational environments. The evaluation procedures became standard for personnel being considered for non-traditional assignments. The Department of Defense established the Innovation Catalyst Program, which provided funding and resources for military personnel to pursue educational opportunities that enhanced their technical knowledge and operational understanding. Riley served on the program's advisory board, helping to develop criteria for selecting participants and designing curricula that would maximize the probability of successful cross-functional contribution. The program funded thousands of military personnel to pursue advanced education that enhanced their value to their organizations. International peacekeeping operations began incorporating technical specialists who could provide both maintenance support and operational capability when circumstances required flexible personnel utilization. Riley's example had demonstrated that comprehensive training could enable individuals to contribute in multiple capacities, reducing the personnel requirements for complex missions. The approach improved mission effectiveness while reducing costs and logistical complexity for multinational operations. Advanced simulation technology was developed specifically to train personnel in the type of integrated technical and operational decision-making that Riley had demonstrated during her mission. These simulators could replicate complex system failures while requiring operational decisions that tested both technical knowledge and tactical judgment. The training systems were deployed worldwide and became standard equipment for developing personnel who could function effectively in multiple roles. The Riley Chun Leadership Academy was established at the Pentagon to provide advanced education for senior military leaders who would be responsible for making personnel decisions that could affect mission outcomes. The Academy's curriculum emphasized recognizing and utilizing exceptional capabilities regardless of traditional organizational boundaries. Graduates of the program became advocates for innovative personnel management throughout their subsequent assignments. Research partnerships between military Organizations and civilian universities expanded to study the cognitive and educational factors that enabled successful cross-functional performance. Riley's case became the foundation for longitudinal studies that tracked personnel who had made similar transitions, providing data about the characteristics and training methods that contributed to success. The research influenced educational policy and career development programs throughout the military. Private sector consulting firms specializing in organizational development began offering services based on principles derived from Riley's example. These firms helped corporations identify employees whose potential exceeded their current roles and develop programs for maximizing human capital utilization. The consulting services were particularly successful in technology companies and engineering organizations where technical expertise could enhance management effectiveness. Military, journalism, and public affairs programs began featuring stories about technical specialists who had achieved operational recognition, creating role models for other personnel who might possess similar potential. Riley's story was featured in documentary films, magazine articles, and social media campaigns that highlighted the value of comprehensive preparation and institutional flexibility. The publicity campaigns influenced recruitment and retention by demonstrating that military service could provide opportunities for exceptional achievement regardless of initial job assignments. The Veterans Affairs Department developed transition programs specifically for military technical specialists who wanted to pursue civilian careers that utilized their comprehensive training and operational experience. These programs recognized that personnel like Riley possessed unique combinations of technical knowledge and leadership capability that could be valuable in civilian technology companies and engineering organizations. The transition programs achieved exceptional success rates in placing veterans in high-responsibility positions. Educational institutions began offering degree programs specifically designed for military technical specialists who wanted to formalize their operational knowledge through academic study. These programs provided academic credit for military experience, while adding theoretical foundations that enhanced practical knowledge. Riley guest lectured in many of these programs, sharing her experience and encouraging students to pursue excellence beyond minimum requirements. The National Security Agency established technical analyst positions that required the type of integrated technical and operational knowledge that Riley had demonstrated. These positions involved analyzing foreign weapon systems and operational procedures, requiring personnel who could understand both technical capabilities and tactical employment. The positions became highly sought-after assignments for technical specialists who wanted to contribute to national security at strategic levels. Military procurement processes were modified to include technical specialists in evaluation teams that assessed proposed weapon systems and support equipment. Riley's insight that comprehensive technical knowledge could inform operational decisions influenced the composition of these teams. The modified procurement processes resulted in better acquisition decisions and improved satisfaction with purchased equipment among operational users. Advanced leadership development programs for technical personnel were established at all major military installations, providing local opportunities for individuals to develop the type of comprehensive knowledge that had enabled Riley's success. These programs included both technical education and operational exposure, creating pathways for career development that hadn't existed before her example. The programs produced graduates who enhanced organizational effectiveness at installations worldwide. The Riley Chen Foundation was established to provide scholarships for children of military personnel who demonstrated exceptional academic achievement and interest in technical fields. The Foundation's mission emphasized the importance of comprehensive education and preparation for unknown future opportunities. Scholarship recipients were encouraged to pursue excellence beyond minimum requirements and to remain open to possibilities that might exceed their initial career plans. Mental health services for military Personnel were expanded to include counseling for individuals who felt constrained by traditional role limitations and wanted to develop capabilities beyond their assigned duties. Rayleigh's example had shown that such ambitions could be healthy and productive when channeled appropriately. The counseling services helped personnel develop realistic plans for expanding their capabilities while maintaining effectiveness in their current assignments. International military competitions began including events that tested integrated technical and operational capabilities, recognizing that modern military effectiveness required personnel who could function in multiple capacities. These competitions were inspired by Riley's demonstration that technical expertise could enhance operational performance. The events became popular with military personnel who wanted to test their capabilities beyond traditional specialty boundaries. Defense Policy Research Institutes established long-term studies to track the organizational and strategic impacts of personnel management innovations inspired by Riley's example. These studies measured improvements in mission effectiveness, personnel satisfaction, and organizational flexibility that resulted from recognizing and utilizing exceptional capabilities. The research provided evidence-based support for continued investment in innovative personnel development programs. The cumulative impact of these developments created a military culture that valued comprehensive knowledge and preparation over traditional role limitations. Rayleigh's example had demonstrated that exceptional preparation could create opportunities for contribution that transcended any institutional barrier. Her legacy was measured not in personal achievement, but in the systemic changes that created possibilities for others whose potential might otherwise remain unutilized. 20 years after her legendary mission, Riley reflected on how one moment of stepping forward had created ripple effects that continued to influence military aviation and personnel management worldwide. Her willingness to prepare beyond requirements and accept responsibility beyond her assigned role had validated principles that now guided career development for thousands of military personnel. The transformation from just a mechanic to institutional innovator proved that individual excellence could create lasting organizational change when supported by leaders willing to recognize merit over convention. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.